Good morning, everybody, and thank you for joining the United Grinding State of Grinding Automation webinar this morning. My name is Jacob Baldwin. I am your host for today's webinar. I am the Director of Corporate Marketing at United Grinding North America. United Grinding's North American headquarters are in Miamisburg, Ohio. That is the building that you're seeing on the screen right now. And inside of this building, our automation solutions team, cylindrical grinding, tool grinding and measuring, and our surface and profile grinding teams are also housed inside of this building. I'm pleased to welcome you to this morning's State of Grinding Automation webinar. Your instructor for today's webinar is going to be Dan Griffin, the automation sales engineer. Dan is a graduate of the University of Dayton, where he studied mechanical engineering technology while working demanding jobs in the aerospace and automotive industries. Dan has now spent nearly a decade working directly with customers in numerous industries to develop manufacturing solutions. Since 2015, he's used that expertise on behalf of United Grinding North American customers, helping to design automation for applications as varied as automatic part loading, deburring, gauging, palletizing, inspection and assembly, along with anything else our customers need help in terms of automation. As you're about to learn, the skills gap continues to widen and competition grows even more fierce, making automation more necessary than ever. One last note before I hand it over to Dan. If you have any questions at any point during the presentation, please type them into the question window. We have a team of people monitoring the chat, and we will have time to answer these questions at the end of the presentation. Once again, thank you for attending. Dan, take it away.
Thank you, Jacob. As Jacob mentioned, my name is Dan Griffin. I'm the automation engineer at United Grinding. Thank you for joining me for this webinar that explores what drives the need for automation. This is my contact information. Feel free to contact me after the webinar if any other questions or comments come up. This slide will also be at the end of the presentation in case you want to write any of this stuff down. So what I'm going to be talking about today are what drives the need for automation, the skills gap and how it relates to manufacturing, integrators and OEMs, what's the difference, and how United Grinding approaches automation with standard and customer automation cells. So I'm going to do kind of a 30,000 foot view of why manufacturing companies are investing in automation. There are a lot of different drivers for this investment, but I'm going to review 3 of the top ones and focus on one. And these topics apply to not only grinding, but turning, milling, welding, sheet metal, a lot of different manufacturing processes. So the 3 main drivers are increased productivity. By having a constant feed of parts, you're guaranteeing that the machine is running and being productive. Difficulty finding skilled operators. Obviously, a lot of skilled operators are becoming very scarce in the workforce, and that is one of the drivers for the need for automation to fill that skilled operator gap. And the greater repeatability and quality. A robot is going to place the part into the chuck the same way every single time with very accurate repeatability, and there's not going to be any surprises. So if you program the robot to do the right thing, it's going to do the same thing every single time. So one of the major topics, the major drivers that I'm going to focus on today is the difficulty in finding skilled operators. And in some cases, it's just a difficulty in finding operators at all. If you visit any machine shop, you'll see the same type of things. You'll see a lot of operators in their mid-50s, mid-60s, and that's a lot of the abundant workforce in a lot of these manufacturing plants. And young people are a little bit less interested in manufacturing, and so therefore you have kind of a less of a pool of potential employees. So the common opinion is that robots take people's jobs. This is a common opinion in the past, but I think these days, as the unemployment rates hit all-time lows, you're seeing that people are changing their opinion on this, and that there might not be enough robots to fill all the open job positions. So looking at some of the numbers here, by 2028, we're looking at, this is an estimate of $1.9 million, 1 million new manufacturing jobs. So that's quite a lot of new manufacturing jobs by 2028. And then 2.6 million jobs will be open after some of the baby boomers retire. So that leaves us with 4.6 million open positions. And how are we going to fill that jobs? We're not going to be able to fill all those jobs with people. So we have to rely on robots. So looking at last year, there was roughly 488,000 unfilled manufacturing jobs. Fast forward 10 years, 2028, there's going to be roughly 2.4 million unfilled manufacturing jobs. That means 53% of open positions will go unfilled. The only way to fill this gap is to either import people or to invest in automation. And instead of an operator loading and unloading a single machine, with automation, the operator can run 3 to 5 machines. So you're actually extending what an operator can do by investing in automation and filling that skills and employment gap there. Looking at some numbers about the time required to fill open positions. So roughly 4 years ago, it was about 70 days it took to fill an open position. Just last year, it was estimated that it takes roughly 93 days to fill an open position. So 3 months of potentially a piece of machinery sitting there idle, or a manufacturing facility having to pay overtime for some of the operators just to keep the machines on and running, which can get pretty expensive. Between 2018 and 2028, U.S. manufacturing output could lose potentially $2.5 trillion in economic output due to the increased skills shortage. Now, these aren't just scary numbers. These are real estimates that could really impact the United States. And this also impacts Canada and Mexico, as well as other European countries, Germany, Italy, Spain, companies where there's a lot of manufacturing, because those countries are also seeing somewhat of a skills gap. So in order to supplement the U.S. output, manufacturing companies must invest in automation. This is a must in order to keep up with the throughput that's required to stay on schedule. So 3 major hows on how and why. So we have the retirements. I mentioned that the baby boomers are getting ready to retire. A lot of the operations that happen in a manufacturing plant, whether it's machine operators, programmers, those types of people are getting ready to retire. So once they retire, who's going to fill those positions? Young people aren't attracted to manufacturing like they once were. A lot of young people see manufacturing as being kind of a dingy, dirty type environment. They see movies like The Machinists, and they think that that's what it's like to work in a manufacturing plant. This picture is a picture of our plant floor, which is very clean. You could quite literally eat off the floor. Everything has its place. There's not oil everywhere. You're not likely to, it's a safe environment. That's the other thing that young people might infer from certain movies, is that working in manufacturing is very dangerous and you'll lose your finger, or this kind of scenario. But it's not really like that as much as it once was, because you have some of the safety standards and ergonomic standards that you have today. The other skills gap is the advanced technology that we have. So the skill floor is really being raised by robots. So instead of having operators that are loading and unloading a machine, you have operators that are going from machine to machine, and many times doing quality checks. They are programming the robots. They are analyzing the data, the throughput, making charts and doing reports about what's happening on the plant floor, instead of just manually sitting in front of a machine loading and unloading parts. So you can't really turn back time when it comes to the required skills, and you can't really change the minds of young people, but you can match grinding machines, which are very advanced pieces of equipment these days, not to mention turning, milling, welding. These are all pieces of equipment that over the last 10, 20 years have been all the advancements that are possible have been implemented in a lot of these machines. You can match these with advanced automation solutions and kind of have this overall big picture of a very technologically advanced manufacturing system. So in the past, as I mentioned, is the operator was just loading and unloading a single machine. Their skills are being spread now to multiple machines. And so based on some surveys that we did and some research that's been done in manufacturing, we see that that grinding automation really is the key to bridging the skills gap. So many of the manufacturing facilities that I've visited recently don't have typical machine operators anymore. They have people kind of running around in white lab coats, keeping the machines running. They're analyzing quality and throughput. And from a survey that was done, it was garnered that 70% of manufacturers who use grinding technology intend to invest in automation in the future. So this is the intention of investing in automation. Some of these companies will, some won't. Obviously, with the price of automation, the price of robots, the price of some of this new technology slowly coming down and being more widely used and more widely implemented, and even becoming more user-friendly, more and more companies are seeing why investing in automation is the key to bridging that labor gap. So some grinding automation facts. This is a picture of one of our in-feed grinding machines. You see you have some grippers moving the parts from station to station. Many times you'll have a robot that's feeding these parts very quickly, because some of the cycle times of these machines are 10 seconds, which cannot have an operator usually move that fast. If the operator goes on a break, for instance, or goes to lunch, that machine is basically sitting idle, not producing any parts. So a lot of different customer concerns that we see with investing in automation, and these are concerns that some have been more prevalent in the past and have been being overcome, and some of them are concerns that are still around today. So the technical restrictions involved in automation. Some of these manufacturing facilities don't have the programming knowledge required to implement these automation cells, and then that along goes with electrical, software, mechanical, those aspects, those technical restrictions. But we've seen a lot of companies, especially large manufacturing companies, make investments, internal investments on hiring the required people that have these skills. The investment costs, it's kind of a common conception that automation is very expensive and only cost effective for high volume production manufacturing, which this is something that seeing some standard machine tending products that are available these days, as well as the price, the overall price of robots and technology coming down. The investment costs are lower, and also the investment costs for lower volume, high mix type applications, those are coming down as well. So people that had more variety of parts and weren't just running the same part every day, they were not wanting to invest in automation because it became a quite expensive endeavor. So these companies are now investing a little bit more into automation because it's becoming a more flexible type. And then we have the project complexity. Automation is thought to be complex and only suitable for high-tech companies. This is changing. A lot of smaller machine shops are getting the knowledge, to be able to run automation and to kind of stay up on the latest trend. Integration of ancillary equipment. So a lot of times these custom automation cells have some upstream and downstream processes that have to be implemented as part of, in order to justify the cost. Obviously, if you're loading and unloading a machine and you have somebody down the line that's manually deburring, it would make sense fiscally to have that person eliminate that operation and have the robot actually do the deburring portion. So once you add some of these deburring or washing station or laser marking, if some post-process and pre-process gauging as well, you can justify a return on investment a lot easier in some of these scenarios. Also, the quality risks involved in anything that you might do that it's outside of the norm. And then the again, the operating costs. It's kind of a common conception that automation has very high operating costs because of spare parts or whatever the case might be from a maintenance standpoint. And this is something that we see as a concern quite a lot of. So all those concerns have been eliminated several different ways. One of the major ways is that manufacturing facilities, machine shops, OEMs, these types of companies have become more proficient. So back just several years ago, 2015, 71% of manufacturing, this is based on a survey that was done recently, 71% were concerned with technological barriers to automation. So 71% of people were worried that there was some sort of barrier that wouldn't allow them to enter into this automation world. It was either too complex, or they didn't have the people skilled enough to handle this type of manufacturing cell. And then you fast forward to just last year, that number dropped significantly. Only 40% were concerned with this barrier into breaking into automation. And these have vanished kind of as OEMs step up to provide kind of turnkey integrated automation. This is something that I think is going to even decrease significantly less as more companies, more manufacturing facilities, whether they're doing turning, milling, welding, sheet metal, stamping, any of these processes, they're going to be more proficient in order to increase throughput and those types of things. So two different scenarios looking at the cost of automation. So some manufacturers might prefer a $100,000 system. Every hour, maybe twice an hour, you have somebody that refills the system with parts, and that just keeps running. So you could fill some of these gaps, like when an operator might take a break, that automation cell is going to keep running. And if they go to lunch, it's going to keep running. It might run for a half hour or an hour or 2 hours or whatever the case might be. And then there's some, in the first scenario, you might have a shop that runs 3 shifts a day, and they're not concerned with running lights out operations. In this other scenario, a more expensive system, you might not need to fill it but every 8 hours. So if you're running 2 shifts, you can fill that 3rd shift with the automation. Also, if you're just running 1 shift, you're going to have basically 2 shifts for the price of 1. So these are 2 different types of scenarios, and everybody has a different return on investment calculation for what's important to them. For some people, they don't even look at ROI, they just look at the overall quality. And they might look at the overall throughput, how many more parts they get out per day, per week, per year, that type of scenario. So we're seeing that a lot of shops are underusing automation. Now this isn't just specific to grinding, milling, turning is also applicable here. 49% of manufacturers have automated 20% or less of their grinding equipment. So they have a lot of different machines out there on the floor, and they're all being hand loaded. And then you have 14%, a much smaller breakdown of manufacturers are automating 81%. So these types of manufacturers, you look at on their shop floor and there's robots everywhere. They're loading, unloading machines, they're doing palletizing. And these are the companies that I see are going to stay in business, while the companies that have less of their, that you're going to have much more higher labor rate applied to each part that passes through. And some companies, that's okay, because they're making high precision, low volume, high mix type of parts. But if you have a higher volume, lower mix type scenario, and you're not investing in automation, your competition most likely is. Looking at some numbers from 2015 to 2018, kind of some of the OEM shift from self-integration to third-party and grinding OEMs. So basically, 10% in 2015 self-integrated their own automation. So this is companies like your your manufacturing facilities that would implement their own robots internally for their manufacturing processes. 44% would rely on third-party automation integrators. So this could be a local automation integrator that will be able to provide kind of a turnkey automation solution. Sometimes turnkey, sometimes you have to rely on multiple different integrators for different processes. So that's kind of a high number back in 2015. And 46% relied on grinding OEMs. So United Grinding would be an example of a grinding OEM, which we provide custom and standard automation solutions. So fast forward to 2018, 36%, up 26% of companies, manufacturing companies, self-integrated automation. So the difference is they hired people internally to handle some of this technology and to implement it themselves. Obviously, they still are going to buy the robots from Fanuc or Kuka or whoever the company might be that supplies the robots. They're gonna cobble the stuff together themselves, and in some cases it works out very well. In some cases, not so much. Then less, 31% from 2015, nearly 13% less relied on third-party automation integrators. So they also increased 10% in relying on companies like United Grinding to provide some of the automation. So this comes along the line of United Grinding, for instance, has a standard products that we've developed that work specifically for our machines. So when companies look at these machine tending automation cells, they know that they're going to work and they're specifically tailored for these machines. Now, other grinding companies do the same types of things, other turning, milling, sheet metal companies, companies that provide sheet metal equipment, stamping equipment. They all have these kind of standard systems that they use for automation. So this is something that is definitely changing in the scope of the overall automation installations. Looking again at some of these numbers, 92% of manufacturers handle automation needs themselves or take advantage of options from the OEM. So that's a big chunk of the pie where maybe some of the integrators are not seeing a lot of this machine tending work as much as they used to. They are still, many of these integrators don't just do machine tending, they do assembly and testing and palletizing and welding and these types of manufacturing processes. So some of the integrators aren't doing as much machine tending as they used to in the past. So now looking at our automation department and how it relates to the overall scope of what our customers like. So for instance, this is our flexLoad system. It is on a Studer S33 machine. It's specifically tailored for OD and ID grinding machines. So this works with a lot of the Studer machines, both OD and ID. And we designed several prototypes, did a lot of life cycle testing, and we redesigned it using a lot of our customer input. This system is fully enclosed, so there's no need for any sort of auto door, which will significantly reduce the time it takes to load and unload a part in the machine. We've seen it as little as 5.5 seconds load unload time. So your machine's only sitting, not grinding, for roughly 5.5 seconds in a perfect scenario. Typically, it could be between 6 and 8 seconds if it's a little bit more of a robust clamp-unclamp cycle. We implemented this with the Fanuc LR mate on a linear axis that travels inside the machine. So looking at some of the numbers for productivity, one flexLoad system running 5 days a week improves productivity 33% per shift. So over 5 years, that increases, that gives you $500,000 in productivity savings. That's just productivity. And one flexLoad system with basic tooling performs 90% of the labor on a shift. So 90% of the time, the operator is not spending in front of that machine. The robot is doing all the required loading and unloading. A lot of times in these flexLoad systems, we'll have a post-process gauge, so the robot's actually able to load and unload the gauge, and that gauge feeds some correction values to the machine, so that if you're getting into a scenario where you're getting outside of your nominal tolerance, that machine's going to auto correct based on the feedback it gets from the post-process gauge. This gives you a little idea of, there's a video of the flexLoad system in operation, and this is hooked up to a Studer S33 machine, an OD grinding machine. The HMI that we developed is a proprietary Windows-based HMI, which is very easy to program. Pretty much everything that you need to do can be done with that HMI as far as setting up new parts and processes. As you see, the robot is traveling into the machine, loading and unloading the part. In some scenarios, you'll have a blow-off nozzle, which is blowing off the part. And in some cases, you would also blow off the fixture to blow off some swarf and oil or coolant that might be in there. So it's in normal case, this load unload cycle can be 6 seconds, but if you want to obviously blow off the chuck or the part, it could be a little bit longer. That's the SPC and reject drawers. Those were actually consolidated. So instead of having just 2 drawers and an SPC and reject, we have 3 full pallet drawers. And those pallets are 300 by 400 millimeters. So they can fit quite a lot of parts. You can see this flexLoad system looks like it's part of the machine, and we designed it that way so that it is more attractive. When a young person sees this piece of machinery, they might be interested in a career in automation or a career in manufacturing. So looking and revisiting these customer concerns, you have, I'm going to look at how these are solved in a certain way. The technical restrictions, that's solved by the OEM built automation for OEM built machines. So we're solving that by providing a built solution turnkey. The investment costs, the productivity improvements are proven out. This is really going to improve your overall productivity, and some of those investment costs are going to be saved by your return on investment. The project complexity, we are developing automation solutions that are essentially plug and play. And we have the integration of additional equipment, so we manage that for you, and a lot of the equipment is going to work directly with our machine. We verify that the communication protocol is there and everything's working and communicating. Like if a post-process gauge has to communicate offset values to the grinding machine, that's being communicated properly before it leaves our floor. The quality risks, our applications and automation team is going to manage those. And then the operating costs. So instead of worrying about those operating costs and having spare parts in-house, you can rely on the United Grinding Customer Care Department to help manage this. So I would like to now take the opportunity to answer any questions that have come through. Jacob, if you're still on the line, could you read the first question for me?
Oh, absolutely. And just before we get into the questions, we do have a couple that came through the question window. So thank you all for engaging with us in that way. I do want to let everybody know that the information that we covered in today's webinar is included in a white paper that we have written, and we will be distributing to everybody who registered for the webinar. So that's just another bonus on top. Dan, the first question is, how do I determine the right form of automation for my particular application, and what's the best way to get started with automation?
So each automation project that we come across kind of has its own unique, everybody has their own specific work pieces that they're working with. They have their own process as far as manufacturing. So we look at all these different aspects. We evaluate the work pieces, the work holding, the weight of the part, how big the part is, and we kind of compile all this into a way to determine what is the best automation solution, whether it fits into one of our standard automation solutions like the flexLoad system, or whether it is a more custom solution. We can determine that by kind of asking you all sort of big set of questions about what you're trying to do, and that would be kind of the best way to determine the right automation solution.
Okay, thank you for that. The next question that we had come in is, how flexible are today's automation solutions? And the second part is, what happens if my processes change often? And then the third part of that question is, do I need to come back to United Grinding every time my processes change, or is there an easy programming solution?
So, yeah, good question. Robotic automation is much more flexible. You have a 6-axis robot. It's able to articulate the part in any sort of different way. So if you have a multiple sets of parts, multiple different part numbers, the robots are able to handle that a little bit easier now more than ever. You can do automatic tool changing on the grippers. So if you have a much wider OD, the robot will actually go to a tool change, a gripper change station, and switch it out. So the robot will be able to grab that larger part and put it in the machine. And to address the concern about what if the process changes, so the HMI that we developed, the program for some of our automation solutions, is going to be very easy to change. So you're going to have kind of a step-by-step guide on how to teach a new part, or how to put in a new piece of work holding, or how to teach a new tray of parts. And it's windows based on our HMI, and a lot of other integrators and OEMs are doing the same type of thing, so that people are used to these window type tutorials on how to do certain things, and it's really a step-by-step guide. So if that doesn't solve it, then we also have training. A lot of times when we do a runoff and acceptance, there's a training aspect involved. So operators and manufacturing engineers, whoever the case might be, can come and get some training while we're running off the machine. And this is really curtailed to what they want to learn. So if there's a specific a specific thing they want to learn, we can curtail that training specifically for them. Does that answer your question?
Yeah, I think that sounds great, Dan. Thank you so much. And we've got a couple more coming through on the line right now, but we'll add those here to the queue. Next question. Is it possible, and if so, worth it to automate in a high mix, low volume production environment, even if my job lot sizes are often in the single digits?
Yeah, I mean, these days you can do a lot with low volume, high mix. There's a lot of technologies out there. You have 3D bin picking. You could have a bin of parts, and the robot knows how to grab those out of the bin. And then the robot can take that part and stick it in front of a vision system. The vision systems have gotten better and better over the years, where you can identify the part either by the geometry of the part or with a barcode or data matrix. And then once that part's identified, you can call up the program on the machine based on that part number. So there's little things like that that you can do with low volume, high mix. And like I mentioned with the automatic gripper change and adjustable grippers. So if you're running a multiple lot sizes and they vary significantly in outside or inside diameter, you can have an adjustable gripper where you basically take the pin out, move the gripper out for a larger OD, and put the pin back in. And we implemented a cell that had a breakdown of all the different part numbers and all the pin locations for that gripper. So there was hundreds of different parts and different geometries of parts, and for each part, the changeover was pretty insignificant. We're talking minutes. You know, it could be 5 to 10 minutes overall. That includes changing over the machine and changing over the automation cell. It could even be less if you're just changing over the automation cell. You turn the automation cell, lock out, and you go in, adjust the gripper, or you could also have an automatic gripper adjustment, like I mentioned before. So smaller lot sizes are possible, and with the technology that we have these days, it is more and more, it's easier and easier to do. I hope that answered that question.
Yeah, sure. Thanks, Dan. We're just going to roll right into the next one here. It says manufacturing companies are also finding it difficult to hire workers who are trained in reprogramming robots for new jobs. It's also an operating cost factor. How is United Grinding addressing this?
So with the training that we offer, that can help significantly. So if you come and during the runoff or acceptance, or if there's a specific robot training that you need, we can offer that here at United Grinding. Also, a lot of the robotic companies offer training, and it's pretty inexpensive overall. I've been to one myself. It was a week-long class, and I left there with a pretty good knowledge of how to run the robot and how to do some simple programming. Obviously, you're not going to be able to be a great programmer in just 1 week of training, but if you take a couple different classes, you should be able to pick up the pieces and be able to. Yeah, there is some cost involved in this, and that's kind of what a lot of these companies are investing internally on their employees to get this training and to learn the new programming languages. I know for FANUC, for instance, it's a pretty simple programming language where you can move the different axes of the robot kind of individually or together, and that kind of scenario, and it makes it pretty simple overall.
And then, Dan, the last question that we're going to cover today, just to be respectful of everybody's time, says, what is the list price of a basic flexLoad system?
It can vary, but the basic list price is typically $125,000 for the base unit, and then you're looking at between 25 and 40,000 for the tooling. So that's part specific tooling. That includes the trays, sets of trays for your parts, and a gripper. So we design those grippers and those trays specifically for your work pieces, and so that's why there's some added cost in that. And then some installation and runoff. So you're looking at basically, in addition to that, 2 weeks or 3 weeks of time. So it's like between $11,000 and $15,000 for both installation and runoff at your facility. So 125 plus 25 to 40, that's 152. So you're looking at between $160,000, $170,000 out the door for FlexLoad system, and that's an example. Could be a little more depending on how much tooling is required.
Okay, and hearkening back to an earlier slide that you showed, the return on investment that a single FlexLoad system can offer, to me that just sounds like a phenomenal value.
Yeah, so a lot of people use a ROI of 2 or 3 years, and so that you can definitely justify that in 2 to 3 years.
Perfect. Well, Dan, thank you very much. That's all the time that we have left for today. Dan, I think we have your contact information one more time on this slide. If anybody has any questions or would like to discuss any other topics about automation or trends in the industry, absolutely feel free to reach out to Dan. I really appreciate you being available to deliver this presentation today. And once more, we will be distributing a white paper, State of Grinding Automation, to everybody who registered for the webinar. Please do take the survey that you'll be receiving via email. I hope you guys enjoyed yourselves and have a great day.
Thanks, guys. Have a good day.